NASA's human lunar exploration plans under Artemis call for sending the first woman and first person of color to the surface of the moon and establishing sustainable exploration by the end of the decade. Working with U.S. companies and international partners, we will uncover new scientific discoveries and lay the foundation for private companies to build a lunar economy. The agency will use what we learn or the moon to prepare for humanity's next giant leap, sending astronauts to Mars. It all starts with US companies delivering scientific instruments and technology demonstrations to the lunar surface, followed by a spaceship called the Gateway in orbit around the moon that will support human and scientific missions, and human landers that will take astronauts to the surface of the moon. The agency's powerful Space Launch System, or SLS rocket, and Orion spacecraft will be the backbone to build the Gateway and transport astronauts to and from Earth. The Space Launch System, or SLS, and the Orion spacecraft are critical to NASA's exploration plans to the moon and beyond. NASA designed the SLS as the world's most powerful rocket for safely sending humans on missions to deep space, and Orion is specifically designed to keep humans alive hundreds of thousands of miles from home, where getting back to Earth takes days rather than hours. The first mission will test the new spacecraft systems flying together for the first time without crew, and the second flight will take astronauts on a flight test around the moon. The third flight of SLS and Orion will carry the first woman and first person of color to the moon. Together, Orion's, SLS, and the Gateway represent the core of NASA's sustainable infrastructure for human exploration. The Gateway will enable months long crew expeditions with multiple trips down to the lunar surface, enabling exploration of new locations across the moon. The Gateway is also designed to operate autonomously as a deep space science outpost, even without crew, and will be built to internationally agreed upon standards. The initial configuration will include a power and propulsion element and a cabin for the crew called the Habitation and Logistics Outpost, or HALO, and be ready to receive logistics supply deliveries. Over time, the Gateway will become a way station for the development of refueling depots, servicing platforms, and a facility for processing samples from the moon and other bodies in support of science and commerce. NASA is working with commercial companies to design and develop human landers that will deliver the astronauts to the moon, with the long term goals of global lunar access and reusable landing system. Private sector innovation is key to NASA's goal of sustainable lunar exploration, and the agency's many public private partnerships are already advancing capabilities for human spaceflight in deep space while stimulating commercial activities. NASA will begin to develop increasingly larger, more capable landers for humans that can carry more cargo and land more precisely. Future landers also will carry large roving instrument kits to locate life sustaining and mission enabling resources on the moon, and collecting and returning samples to the Gateway. NASA has also outlined a concept for how robotic and human explorers will put in place infrastructure for a long term sustainable presence on the moon. These include a lunar terrain vehicle, or LTV, to transport crew around their landing zone, a habitable mobility platform to allow crews to traverse the moon for up to 45 days, and a surface habitat that would house as many as 4 crew members on shorter surface days. NASA also continues to work with companies to address the challenges of living in space, such as using existing resources, options for disposing of trash, and more. Missions to the moon are about 1,000 times farther from the Earth than missions to the International Space Station, requiring systems that can reliably operate far from home, support the needs of human life, and still be light enough to launch. These technologies will become increasingly more important for the 34 million mile trip to Mars. Exploration of the moon and Mars is intertwined. The moon provides an opportunity to test new tools, instruments, and equipment that could be used on Mars, including human habitats, life support systems, and technologies and practices that could help us build self sustaining outposts away from Earth. Living on the Gateway for months at a time also will allow researchers to understand how the human body responds in a true deep space environment before committing to the years long journey to Mars. The agency released its top objectives for a 30-day two-person Mars surface mission on Tuesday, May 17, and asked the public to provide feedback on how the planning is going. Submissions were initially due on May 31st, but the deadline was recently extended to June 3. NASA aims to launch astronauts to Mars by the late 2030s or early 2040s. Making that vision a reality will be challenging, assuming the funding and technology come into play at the right time. For example, the round trip travel time would still be about 500 days given the distance between Earth and Mars. Gravity, or the lack thereof, would also be a problem, as current generation spacecraft look nothing like those seen in movies like The Martian shown in 2015. The astronauts will arrive on the red planet after months in microgravity and face a significant road to recovery, even to operate in the partial gravity of Mars, which is roughly one third of that of Earth. NASA suggests that one way to address this issue might be having the crews live in a pressurized rover during their mission. We want to maximize the science, so we allow them to drive around before they become conditioned enough to get into spacesuits and walk and maximize that science in 30 days, Kurt Vogel, NASA Director of Space Architectures, said in a 30-minute YouTube video. The mission plan is in the early stages and could change considerably, but so far, NASA envisions using for a habitat like spacecraft to ferry crew members to the red planet using a hybrid rocket stage. Powered by both chemical and electrical propulsion, four people would make the long journey, with two alighting on the surface, somewhat similar to the model seen in the Apollo program with three astronauts. Roughly 25 tons of supplies and hardware would be ready and waiting for the crew, delivered by a previous robotic mission. These supplies would include a crew ascent vehicle, already fueled and ready to go for the astronauts to make it off Mars and back into orbit around the planet. A spacecraft entering the Earth is able to use a drag generated by interaction with the atmosphere to slow down. This allows the spacecraft to land safely on Earth's surface, provided it can survive the related heating. But the atmosphere on Mars is about 100 times thinner than Earth's. That means less potential for drag, so it is impossible to land safely without some kind of aid. Some missions have landed on airbags, such as NASA's Pathfinder mission, while others have used thrusters, NASA's Phoenix mission. The latter, once again, requires more fuel. A Martian day lasts 24 hours and 37 minutes, but the similarities with Earth stop there. The thin atmosphere on Mars means it can't retain heat as well as Earth does, so life on Mars is characterized by large extremes in temperature during day and night cycle. Mars has a maximum temperature of 30 degrees Celsius, which sounds quite pleasant, but its minimum temperature is negative 140 degrees Celsius, and its average temperature is negative 63 degrees Celsius. The average winter temperature at the Earth's South Pole is about negative 49 degrees Celsius. So we need to be very selective about where we choose to live on Mars and how we manage temperature during the night. The gravity on Mars is 38% of Earth, so you'd feel lighter, but the air is principally carbon dioxide, with several percent of nitrogen, so it's completely unbreathable. We would need to build a climate controlled place just to live there. SpaceX plans to launch several cargo flights, including critical infrastructure such as greenhouses, solar panels, and, you've guessed it, a fuel production facility for return missions to Earth. Life on Mars would be possible, and several simulation trials have already been done on Earth to see how people would cope with such an existence. The final challenge is the return journey and getting people safely back to Earth. Apollo 11 entered Earth's atmosphere at about 40,000 kilometers per hour, which is just below the velocity required to escape Earth's orbit. Spacecraft returning from Mars will have re-entry velocities from 47,000 kilometers per hour to 54,000 kilometers per hour, depending on the orbit they use to arrive to Earth. They could slow down into low orbit around Earth to about 28,800 kilometers per hour before entering our atmosphere, but you guessed it, they need extra fuel to do that. If they just barrel into the atmosphere, it will do all the deceleration for them. We just need to make sure that we don't kill the astronauts with G forces or burn them up due to excess heating. These are just some of the challenges facing a Mars mission, and all the technological building blocks to achieve this are there. We just need to spend the time and the money and bring it all together.